Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your same module, database design concepts, and the same chapter, that is chapter number 12. So let's start with the previous class session, what we have covered in the last class, and then move to the today's topic. So in the last class we have started with the evaluation of the expressions, that is how to evaluate the expressions, or what are the various methods to evaluate the expressions. So what is expression? That is whenever we give the syntax, whenever we give the command that is expressed in the mathematical form, that is an expression. And whenever we evaluate by using any mechanical terms, any technical terms, any algorithm, that is known as the evaluation of the algorithms. And there are two criteria for evaluation of the algorithms or expressions, that is the materialization and the pipelining. So one method is a divide the term into different, or divide the expression into various materials, and divide the expressions into various pipelining, that is the materialization and the pipelining. And the cost of the both the parties, or both the techniques, that is very differ, that is the materialization and the pipelining approach. So we also discuss about the materialization, that is used to evaluate, and that is represented by the pictorial representation of this one. This is one of the example of the materialization. This is the pictorial representation of the expression, that is how to represent in a pictorial representation. Then there is a double buffering, that is using the two buffering with one containing execution of the algorithm while the other being written out. So there are two buffering that is used, that allows the algorithm to execute more quickly by performing CPU activities in parallel with the input-output activities. That is a double buffering. That means how to buffer in a double way, that is there are two buffering that is continuing. Next is the pipelining. Pipelining means how to use the terms that is used in the terms of the pipelining methods. Next is the pipelining method, that is also used as a query evaluation efficiency, that is reduce the temporary file, that is the temporary files are removed by using the concepts of the pipelining methods. And the operations are performed or passed to the next operation, that is one operation is performed, that the result is passed to the next operation, then next operation, next operation. That means the output of one expression is transferred to the input, or becomes the input of the next expression, and so on, going to the next operations in the pipelining method. That is a pipelining. That means a line is maintained with the pipe, that is a pipelining method. And this is one of the example that is used, that is using the sigma and the pi. And creating a pipeline can provide two benefits. There are two benefits that is used in the pipelining. The first of all is that eliminates the cost of reading and writing the temporary file. So there is a lack, or we can say that there will be a saving of the cost, there will be a saving of the reading and writing times that is used in the temporary relations, that is reducing the cost of the query evaluation, that reduce whatever the code that is required, that is displayed in the query evaluation. Then next benefit is that it can start creating, or it can start generating query results quickly if the root operator of a query evaluation plan is combined in the pipelining with its input. So whatever the input that is given, whatever the query that is given, that is quickly carried out, that is done by using the pipelining methods. Then we have discussed about the implementation of the pipelining, that is how to implement the pipelining in the method. There are three methods on which in which we can execute the pipelining. One is the demand driven pipelining, then is the producer driven pipelining. So there are two methods, one is the demand driven, one is the population or producer driven pipelining. And each operation in a demand driven can be implemented as an iterator that provides the following functions. So these are the functions that is used for the demand driven functions, that is open, next, close. So these are the functions, these are the three functions that is used, or that is used as a materialized, that is provided with the pipelining. And after a call to the open, each call to the next returns the next output tuple of the operation. The implementation of the operation in turns call the open and the next function, and the state is also changes from the one part to the another part. For example, for an iterator implementing the select operation using linear search, the open operation starts a file scan, and the iterators start records the point to which the file has been scanned. And there will be a pushing method, there will be a pulling method, there is a lazily method that is used. Then evaluation algorithm for the pipelining, that is what are the various evaluation algorithm that is used for the pipelining, that is the evaluation algorithm for the pipelining. Some operations such as the sorting are used as a blocking operations, that is they are not able to output any result until all the tuples from the input have been examined. That is they are not providing any result that is used to give the result, that is used to give the tuple, that is used to give the rows that have been examined. Other operations such as the join are inherently blocking, but specific evaluation algorithm may be blocked, may be used, that is known as the double pipeline join algorithm join techniques. This is the algorithm that is used for the double pipeline join algorithm. Then we have finished this chapter, that is the chapter number uh, that we started with the chapter query optimization method is used to optimizing the query. So that is the process of selecting the most efficient query evaluation plan among the various strategies that is available for processing a given query. That means selecting the most efficient queries evaluation plan. That is what is the various method or what is the basic query optimization plan, that is the most efficient query evaluation plan that is used among various strategies that is usually possible for processing a given query, especially if the query is complex. So whenever the query is complex, that is used for the query optimization. We do not expect users to write their queries so that they can be processed efficiently. Rather, we expect the system to construct a query evaluation plan that minimizes the cost of the query evaluation. So whatever the code that is used, whatever the plan that is used, that minimize the cost of the query evaluation, that is the query optimization. That is optimize the query. That means using the less cost technique that is used for the query optimization. One aspect of optimization occurs at the relational algebra level, where the system attempts to find an expression that is equivalent to the given expression but more efficient to execute. So one of the major aspects of optimization that is available at the relational algebra level, to find an expression, where to get the expression that is used to execute. The difference in the cost between the good strategy and the bad strategy, that is, it depends on the cost that makes a difference between the good strategy and the bad strategy. And whatever the course that is required, that is used with the best strategy and the bad techniques, and maybe several orders of the magnitude. Hence it is worthwhile for the system to spend a substantial amount of time on the selection of a good strategies for processing a query, even if the query is executed only once. So whatever the amount that is given, whatever the data that is given, that will execute the query, that will execute the time for the queries. Next, we have also considered the overview of the query, that is what is the query, or what are the various overview of the query that is used in the design. This is the overview. So consider the following relational algebra that is used, that is expression that is used for the queries. This is the pi, then name, title, then there will be a sigma that is used, then instructor teaches, a course ID, and the title. This is the equivalent expression. These are the various expression, that is the initial expression tree and the transferred expression tree. This is the evaluation plan, that is how to plan out the evaluation, that is the cost effective evaluation. Then we also talked about the query evaluation plans, that is what are the various plans that is used for the query evaluations, or what are the various methods, what are the various plan out that is used for the query evaluation methods. The next is the transformation of the relational expression, that is how to transform the, or how to transfer the relational expressions into multiple forms. A query can be expressed in several different ways with different cost of evaluation. So a query can be expressed in a multiple ways, in a several different ways that can be expressed, that can be used with a different cost of evaluation. In the selection, or in this section, rather than the relational expression as given, we consider alternative equivalent expression. That is we are considering the alternative equivalent expression that is used for the relational expressions. Two relational algebra expressions are said to be equivalent if on every legal database instance the two expressions generate the same set of tuple. So if I say about the two relational algebra expressions, if I say about the equal operation that can be said, or that is every legal instance that is used, the two expressions generate the same set of tuple, that is they are generating the same set of tuple, that is they produce the same rows, they produce the same output as the output of the relational expression. In SQL, the inputs and the output are multi-set of tuples, and the multi-set version of the relational algebra is used for the evaluation of the SQL queries. This is one of the methods, that is a pictorial representation of the evaluations or equivalence. Then equivalence rules, that is equivalence rule says that the expressions of two forms are equivalent. We can replace the expression of the first form by an expression of the second form. So whatever the forms, whatever the rule that is used, that is used for the expression of the two forms, that is very equivalent, that is used in the equivalence rule. We can replace an expression of the first form by an expression of the second form. That is, this is a rule, that is two are equal. We can replace any one, we can replace any rule with the second form, or vice versa. That is, we can replace an expression of the second form by an expression of the first form. We now list a number of general equivalence rules on a relational algebra expressions. So these are the various methods, and these are the various rules that is studied about. That is a cumulative, natural join, associative. That is these are different rules. And this is the example of the transformation. That is how to transform the content, how to transfer the relational algebra queries. So these are the three methods. That this is the relational, or this is the university example that is used. Then there is a join ordering, that is how to join, what are the different order, what are the different criteria, or in which order the join can be performed. That is a join ordering. So the good ordering of the join operations is important for reducing the size of the temporary results. Hence, more query optimizers pay a lot of attention to the join order. So whatever the optimizers that is available, that is also paying the attention that is in the join order. And there is a natural join operation, that is also associative operation. Therefore, for all relations, that is R1, R2, R3, these are the three combined, that is joined with each other, that is the R1 and the R2 are joined, and the output of both these are combined with the R3. That is very equal to the R1 is different one or separate one, and the R2 and the R3 are combined together into the join operation. Although these expressions are equivalent, the cost of computing them may differ. Whatever the cost that is required, that is very different from the join to join. Note that there are no attributes in common between the pi course ID title course and the instructor, so that join is a Cartesian product. Then how to enumerate the equivalent expression, that is how to give the values to the equivalent operations or expressions. So query optimizers use equivalence rules to systematically generate expressions equivalent to the given query expression. Conceptually, this can be done as an outline in the figure 13.5. The process proceeds as follows. Given a query expression E, the set of the equivalence expressions EQ initially contains only E. Now EQ is matched with the equivalence rule, that is the rule that is given in the equivalence expressions. The preceding process is extremely costly both in the space and the time, but optimizers can greatly reduce both the space and the time cost. Using two ideas, that is used in the two ideas. These are the two ideas that is generally used. So if we generate the expression, then E1 and the E2 have the identical sub expressions. Then next is estimating statistics of the expression result. This is the catalog information, that is how much is required, how much blocks are required, what is the histogram. This is shown with the help of the histogram. Then next is selection size estimation, that is what is the selection size that is used in the estimation that is used for the query optimization. That is the today's topic, that is selection size estimation. So let's start with the today's topic, that is a selection size estimation. So the size estimate of the result of a selection operation depends on the size selection predicate. So whatever the size estimate, or whenever we estimate that size, that is result of a selection operation, that depends on the selection predicate. So whatever the predicate, whatever the selection criteria that I am using, that is the size that is estimate for the selection operation. We first consider a single quantity or equality predicate, then a single comparison predicate, and finally combinations of predicates. So first of all, it considers a single equality predicate, then single comparison predicate, and finally combinations of predicate. So first one is sigma A equals to AR. So if I assume uniform distribution of the value that is given with the equal probability, the selection result can be estimated to have NR divided by V, that is the AR tuples, assuming that the value A appear in the attribute A of some records of A. That is the content. This is the method that is used, that is a sigma A equals to A, that is done in the content of the method, that is the content of the criteria, that is the uniform distribution of the values. Then next is the computing and maintaining the statistics. So conceptually, statistics on the relation can be thought of a materialized view which should be automatically maintained when relations are modified. So whenever the relations are modified, that can be easily maintained as a materialized view. Unfortunately, keeping statistics up to date on every insert, delete or update to the database can be very expensive. On the other hand, optimizers generally do not need exact statistics, that is an error of a few percent may result in a plan that is not quite optimal being chosen. But the alternative plan chosen is likely to have a cost which is within the few percent of the optimal cost. Therefore, it is acceptable to have statistics that is very approximate statistics. Next is a pi a is less than v, that is consider this relation if the actual value that is used in the comparison is available at the cost estimation. This is the output, this is the formula that is used. The next is complex selections also include the conjunction, that is the selection is a selection of the form this one. Then disjunction, then there is a negation. Next is the joint size estimation, that is how to use the or what is the size estimation of the joint operation. So next is the joint size estimation, that is how to estimate the joint size, that is what is the joint size or what is the size that is required for the joint operation, that is the joint size estimation. So in this section we will see how to estimate the size of the result of a joint, that is what is the output, what is the size that is available in the joint operations. The Cartesian product, that is the R into S, that is the R multiplied by S, that is the NR multiplied by NS tuples. That means R into S means N by NR is multiplied by the NS, and each tuple of the R into S occupies LS or LR plus LS bytes, from which we calculate the size of the Cartesian product. That is a cross multiplication, or we can use the Cartesian product for operating that tuple for operating the size, that is each tuple containing the R into S multiple operation that is used in performing the operations. Then estimating the size of a natural join is somewhat more complicated than estimating the size of a selection. So whatever the size that is required for the estimation, whatever the size that is required in the selection operation, that will be carried out by the selection method, that will be carried out by the multiple method that will be used for the selection operations. Then whatever the estimated size that is required for the size of the selection of the Cartesian product, let RR and the SS are the relation. So let the relation name be the RR and the SS. If R is intersected with the S, that is equals to phi, that is the relations have no attribute in common, that is there is no attribute that is common in the R and the S. Then R and join R joined with the S is the same as the R into S, and we can use our estimation technique for the Cartesian product. So we can use the Cartesian product, we can use the Cartesian method for calculating the Cartesian level. And if the R intersection S is a key for the R, then the tuple will be joined, then the tuple will be carried out with at most one tuple from the R. Therefore, the number of tuples in the R and the S is no greater than the number of tuples in the S. The case where R intersects with the S is a key for the S is the symmetric to the case just described. And if the R intersection key forms a foreign key that is used, so the number of tuple that is required is the number of tuple that is required in the S. And the most difficult case is when R is intersected with the key that is neither the nor the R nor the S. In this case, we assume, as we did for the selection, we did the value that is appears with each probability or equal probability. So this is one of the method, or we can estimate the size of a theta join, that is a R modulus S, by rewriting the join as the sigma 0 that R into S, and using the size estimates for the Cartesian products along with the size estimates for the selection. So whatever the size estimate that is required, whatever the theta that is required, whatever the join that is required, that is available with the selection operation. So to illustrate all these ways of estimating joint sizes, consider the expression. So whatever the size estimation that will be required, whatever the joint that is required, that is expressed in the following format. So student joins with the takes. So there will be a join operation that will be carried out between the student and the takes. Assume the following catalog information about the two relations. There will be n student, that is a 5000, f student, that is a 50, which implies that the b student equals to 5000 divided by 50. That is, whenever the total number is divided by the frequency, that will give the student, that is a 100. Then the n takes, f takes, that means b takes equals to 10,000 divided by 25, that is a 400. And the b or the fifth, that is the ID takes equals to 2500, which implies that only half of the students have taken any course. That is unrealistic, but we can use it to show that our size estimates are correct even in the case of the average. The attribute ID in takes is a foreign key on the student, and the null values do not occur in the takes. So whatever the attribute that is given, that will be available on the student, and the null value do not occur in the takes relation in the takes format. The next is the size estimation for the other operations. So whatever the size estimation that is required, that is also required for the other operations. So we outline below how to estimate the size of the result of other relational algebra operations. The first one is projection. So these are the various operations, these are the various, we can say, the operation that will be carried out on the size estimation. The first one is the projection, that is how to project the things or how to manage the things. The estimated size, that is the number of records or the number of tuples of a projection of the form, that is pi AR is VAR, since the projection eliminates the duplicate. So projection means projecting the things, or we can say the selecting the thing, that is done by the projection. Then there is the aggregation, that is the size of the AGFR is simply VAR, that so since there is only one tuple in the AGR for each distinct value of A. Then there is a set operations, that is if the two inputs to a set operation are selection on the same relation, then we can rewrite the set operation as a deduction, conjunction and negation. So there are three parts that is used, there are three operations that is used, that is a distinction, that is a conjunction, or the negations. And we can also rewrite the sigma by using the union size, that is the sigma theta 1 and the v theta 2, that is the relation R. Similarly, we can rewrite the intersection as a conjunction, or we can rewrite the set difference by using the negation, so long as the two relations participating in the set operations are selections on the same relation. Then next is the outer join, that is the estimated size of the R and the join S, that is R is joined with the S plus the size of the R. The next is the estimation of the number of distinct values. So whatever the estimation that is given of the distinct value, that is the estimation of the number of distinct values. Then choices of the evaluation plan, that is what is the choice that is required for the evaluation plan, that is what is the choice that is required for the evaluation plan. So it depends on the choice to choice, it depends on the person to person, that is how to evaluate, or what are the various evaluation plan choices that is required for the evaluating the plans, or for taking out the plans for the evaluation. So generation of expressions is only a part of the query optimization process, since each operation in the expression can be implemented with different algorithms. So there are different algorithms that is used, there are different optimization technique that is used, that is a query optimization process, since each operation in the expression can be implemented with different algorithms. An evaluation plan defines exactly what algorithm should be used for each operation. So whatever the algorithm, whatever the, we can say, the methods that will be used for the each operation, and how the execution of the operation should be coordinated, that is the evaluation plan, that defines exactly what algorithm should be used, what method should be used, what operation should be used, and how the execution of the operation should be coordinated. And there will be a cost-based optimizer explore the space of the technique, the space of the evaluation techniques. Then next is the cost-based join order selection, that is on the basis of cost how to join the operations, how to merge the operation, that is the inserting join operation. The next is the cost-based optimization with the equivalence rule. So this is the cost-based optimization that is used with the equivalence rules. The next is the heuristic in the organization, that is how to, or what are the various methods that is used with the heuristics in the organization, that is how to apply the heuristic in the organization. So optimizers also uses the heuristic approach to reduce the cost of the optimization. So one of the drawback of cost-based optimization is that the cost of the optimization itself. So whatever the cost that is required for this technique, that is cost-based optimization, is very tricky as compared to the heuristic approach. Although the cost of query optimization can be reduced by using various algorithms, but there are different evaluation plans that will be carried out for the finding the optimal plan that is required for the computational effort. Hence, the optimizer uses the heuristic or the heuristics approach to reduce the cost of the optimization. An example of a heuristic rule is the following rule for transforming the relational algebra queries. What various examples, that is perform the selection operations as early as possible. Heuristic optimizer use this tool without finding out whether the cost is reduced by this transformation. And this is the perform projections only, or perform the join operations only. This is the left deep join tree, that is the non leaf or non left join tree. Then how to optimize the nested subquery, that is what are the various techniques to use the nested subqueries. One query is carried out in the another query, that is nested subqueries, that is done by the correlation variables. And the SQL evaluates the overall query, that is conceptually by computing the Cartesian product of the relations in the outer from clause and then testing the predicates in the where clause for each tuple in the product. So we use the from clause with the Cartesian product that is used to test the where clause, that is for used for the each tuple in the product. In the preceding example, the predicate test if the result of the subquery evaluation is empty. So in the preceding example, we also take the method, we also take the form that is used to evaluate the method, that is a query or the subquery evaluation is empty or not. This technique for evaluating a query with nested subquery is known as the correlated evaluation. And SQL optimizers therefore attempt to transfer nested subqueries into join where possible. Next is the materialized view. That is, what is a materialized view? So whenever we define or whenever a view is defined, normally the database stores only query defining view. So when view is defined, normally the database stores the only that part of the query that is define the view or that defines the view. That is known as the materialized view. In contrast, a materialized view is a view whose contents are computed and stored. So materialized view means a view that is in which the contents are computed, contents are modified, or contents are sorted out and stored. Materialized view consists redundant data in that their content can be inferred from the view definition and rest of the database content. So whatever the redundant data, whatever the views that constitute the redundant data, that is their contents can be inferred or their contents can be modified from their techniques that is used for the rest of the database content. However, it is much cheaper in many cases to read the contents of a materialized view than to compute the content of the view by executing the query defining the view. So materialized views are important for improving the performance in some applications. So these are very important part for improving the performance in various applications. So consider the view which gives the salary or total salary in each department. So this is that is how to create a view. This is a create view, then department total salary, and these are the two attributes, that is the department name and the total salary. As, that is the as means creating this view and run the query, that is a select department name sum salary from instructor, that is grouped by the department name. So display the department name list, display the department name attribute, and the salary, that is the sum of the salaries, or that is addition of all the salaries from the table instructor, that is grouped by the department name. That is group means division of the department name, division on the basis of the department name. Suppose the total salary amount at a department is required frequently, that is whatever the amount that is required frequently. So computing the view requires reading every instructor, that is every database that is used, that is pertaining to the department, and summing up the salary amounts. And next is the view maintenance, that is view maintenance means the maintenance will be carried out or the maintenance will be taken out, that is a view maintenance. So a problem that is carried out with the materialized view is that they must be kept up to date when the data used in the view definition changes. So whenever the material that will be used in the definition view that can be changed, that must be kept up to date with the content with the materialized view that is taken. For example, if the salary value of an instructor is updated, so whenever the salary of an instructor that is taken out, that is updated, so the materialized view will become inconsistent with the underlying data and must be updated. The task of keeping a materialized view up to date with underlying data is known as the view maintenance. So whenever I need that the data will be maintained consistent or the data will be automatically updated into the database, that is known as the view maintenance. Views can be maintained by manually written code. That is, for every piece of code that updates the salary view can be modified to also update the total salary amount that is given in the salary. And most database system performs the immediate view maintenance, that is incremental view maintenance is performed as soon as the updates are occurred. The next is the incremental view maintenance, that is how one method is used with the increment view, or how one view is used as the increment method to handle a complete expression. The changes to a relation that can cause the materialized view to become output or out of date are insert, delete, and the update. To simplify the expression, to simplify the description, we replace updates to a tuple by deletion of the tuple followed by the insertion of the updated tuple. Then next is the join operation, that is how to join the operation, that is the merging of the operation, taking the union of the operation. Then next is the selection and projection operations, that is selection and the projection operation will be carried out. Then next is the aggregation operation, that is aggregation means finding the sum of finding the carried out terms in terms of the aggregation method. And the aggregate operators that is used in the SQL are count, sum, average, min, max. So these are the 5 aggregation functions that will be carried out. So one is the count function, one is the sum function, one is the average function, one is the min function, one is the max function. Count means counting the value or compute the total attribute that is given, that is followed by other attributes. Sum means adding up all the materialized view, adding up all the views that is available in the we can say the available in the database concepts. Then there is a average, that is a AVG. Then there is a min max. That means finding the minimum terms out of the available terms, finding the maximum terms out of the available terms. The next is the other operation that is used. The set operation intersection is maintained as follows. So this is next is the handling expressions, that is how to handle the expressions by using the various query techniques. The next is the query optimization and the materialized view, that is how to optimize the query and what are the various views that is available in the materialized view. That is the query optimization and the materialized view. So query optimization can be performed by treating the materialized view just like the regular relation. So whenever we use the materialized view, it can treat the same relation, it can treat the same table that can be used in the database. So there is no difference between the table, normal table, and the materialized view. However, materialized view offer further opportunity for the optimization, that is rewriting the queries to use the materialized view and then replacing the use of the materialized view with the view definition. And the bibliography notes that is given pointer to the research that shows how efficiently and effectively the query will be performed or the materialized view will be maintained. The next is the materialized view and the index selection, that is using the materialized view with the index selection, that is how to use the index in the materialized view. That is of the materialized view selection, that is namely what is the best set of the views to the materialized. So what is the best method to view of use as a materialized view. This decision must be made on the basis of the system workload. So whatever the system workload, whatever the content that is used, that will be available on the system uploadation method. That is the sequence of the queries and updates that reflects the typical load on the system. One simple criteria that is used to select a materialized view that minimize the overall execution time as well as the cost of the concepts. Now next is the advanced topics in the query optimization, that is the next part. So let's take a break right now only for 5 to 10 minutes. Then after the break, let's start with this topic, that is advanced topics in the query optimization. So let's take a break right now. So next is the advanced topics on the query optimization. That is, what are the various advanced topics that is available in the query optimization. So there are n number of opportunities for optimizing the queries, beyond which there are so far. That is, first is the top K optimization. That is, there is a limit that is available. That is, a top K means the top priority will be given to the optimization queries, and the many queries fetch the result that is sorted on the some attributes and requires only the top K result, that is for some K. That is, the top K optimization means searching of the query and getting only the first top records that is available in the optimization methods. Then next is join minimization. That is, there will be a less join. So whenever the queries are generated through the views, sometimes more relations are joined than are needed for computation of the query. That is, sometimes the more and more relations, more and more operations, more and more, we can say, the tables are joined together that are needed for the computation of the query. For example, a view V may include the join of the instructor and the department, but our use of the view V may use only the attribute from the instructors. The join attribute department name of the instructor is a foreign key that is referencing the department. That is to declare the node null. Then next is the next approach, that is next advanced feature, is the optimization of the update. So whenever there will be update, that must be optimized. So whenever there will be a set update, whenever there will be a subquery update, that must be updated automatically. That includes in the set and the where clauses. So that is a set the amount to the 1 lakh, set the column to the 1 lakh, and the where clauses look for the finding the condition or for getting the condition. That is the optimization of the updates. And there is a problem that is affected of the updates that is associated, that is known as the Halloween problem. That is named because it is recognized by the Halloween Day at the IBM. Halloween Day is celebrated in the USA. Then next is the multi-query optimization and the shared scan. So whenever there is a batch of queries that are submitted together, then a query optimizer can potentially exploit common sub-expressions between the different queries that evaluates them once and reusing them whenever there is a requirement. The complex query may in fact have the sub-expression that is repeated in different parts of the query, which can be similarly exploited to reduce the query evaluation cost. And such optimization is known as the multi-query optimization. That is how to multiple or how to query the multiple operations and how to get the multiple operations, that is getting the multiple queries. Common sub-expression elimination optimizes the sub-expressions shared by the different expressions in a program by computing and storing the results. And there will be a shared scan optimization that is also worked as follows for reading the relation, for making the relation. The next is the parametric query optimization. That is how to use the parametric query optimization that is used with a heuristic approach in many databases. So in the parametric query optimization, a query is optimized without being provided specific value for its parameter. So any specific value is not optimized, or the query is optimized without being produced or without being provided specific values for the parameter. For example, department name in the preceding example, that is used as the specific parameters. Now next is a summary, that is a summary of the chapter, that is what we have covered in chapter number 13. So given a query, there are generally a variety of methods for computing the answer. So whenever a query given, there are multiple methods that is used to solve the method or used to process the query. But the best alternative method that is required, that is taken out, that is known as the query optimization. So the process of finding a good strategy for processing a query is known as the query optimization. The next point is the evaluation of the complex queries involves many access to the disk. That is, there are many accesses that is available to the disk, that is the evaluation of the complex queries. Since the transfer of data from the disk is slow relative to the speed of the main memory and the CPU of the computer system, so it is very valuable to allocate a considerable amount of processing to choose the best method that minimizes the disk access. The next is there are a number of equivalence tools that can be used to transform an expression into the equivalent one. So there are multiple equivalence tools that is available in the chapter, that is we have covered in the chapter, that is used to transform an expression into the equivalent rule. That is two relations are said to be equal if they operate on the same methods. We use these rules to generate systematically all the expression that is equivalent to the given query. And next is each relational algebra expression represents a particular sequence of operations, and the first step that is used is to find a relational algebra expression that is equivalent to the given expression and the estimated cost that is left to execute. The next is the strategy that the database system chooses for evaluating an expression or operation that depends on the size of each relation and the distribution of the values within the column. So whatever the values, whatever the distribution that is carried out, that will be taken out by the resources, that will be taken out by the methods. So they can make the base, or that they can base the strategy choice on the reliable information. Database systems can also store the statistics for the each relation R. This includes the method, that is the number of tuples in the relation R, the size of a record tuple of a relation R in bytes, the number of distinct value that appears in the relation R for a particular value, for a particular attribute. Then most of the database system uses a histogram to represent the number of values as an attribute with each of the ranges that is available in the histogram. That is also used for computing the sampling. Then next, statistics also allows to statistics or the statistics statistics that allows us to estimate the size of the results of various operations as well as the cost of executing the operations. So this stats also available, that is used to estimate the cost of the result of the estimate the size of the result of the various operations that will be carried out. That will be very effective method for evaluating the cost of the given expression. Alternative evaluation plans for each expression can be generated by using the equivalence rules, and the cheapest plan across all the expression can be chosen. So whatever the operation or whatever the content that will be available, that will be chosen in the sub rules. Then next is we can use the heuristic approach. We can use the heuristic method to reduce the number of plans considered. So we use the method that we done, that is a heuristic plan that will be carried out, so that the number of the plans considered is hereby to reduce the cost of the optimization. Then materialized view can be used to speed up the query processing. So the materialized view can be taken up to speed up the query processing. Then the number of advanced optimization techniques have been proposed, such as the top queue optimization, join minimization, optimization of updates, multi-query optimization, and the parametric query optimization. These are the various advanced optimization techniques that will be proposed, that have been taken out. And these are the review terms that will be taken out, that is the query optimization, transformation of expressions, equivalence, and these are the practice exercises of this chapter that will be carried out. These are the multiple questions. Now next is the chapter number 14. That is a part 3, basically part 4, that is a transaction management. That is how to manage the transaction, what is the transaction management, what is that, or now the main role is on the transaction management. So let's start with the transaction management in the next class, that is in the tomorrow's class. So chapter number 14 is a transaction. What is a transaction? How to use the transaction. So that's all for today's session. Thank you so much everyone for listening me. If there is any doubts, any confusions, any clarification, you can ask the doubts. And we will meet tomorrow with the new chapter, that is the chapter number 14, that is the transactions. Thanks a lot everyone. Bye bye.